Good morning, class. Today's lesson, what we're going to do is we're going to find the distance between a point and a line and the distance between two lines when they're parallel. And for these, there is quite a few steps. We're going to be using a lot of algebra for this. So go ahead and take good notes. I am going to do some extra examples with this. If you feel like you got it after the first couple, you can just kind of stop the video there and move along. But I put on some bonus examples here at the end, and that hopefully will help out those that need them. So the first thing we need to know is we need to know what it means when it asks the distance between a point and a line. So when it says that, what that means is it wants the shortest distance between a point and this line. It's not saying they want this one or this other one, because you could have like an infinitely many number of distances. What they want is the shortest distance. And what that would mean is that it's the line that's perpendicular to the line from the point. So I'll go ahead and just read this quick. It's the distance between a line and a point not on that line is the length of the segment that's perpendicular to the line from the point. And we can see here the distance would be this distance right there. We looked at Euclid's parallel postulate a few sections ago. Now there is another one. It's called the perpendicular postulate, and that says that if given a line and a point not on that line, so I'll go ahead and sketch out what that would look like. So if we're given a line and a point that is not on that line, then there exists exactly one line through the point that is perpendicular to the given line. So just like the parallel postulate said there's only one line parallel to the line through the point, this would say there's only one line perpendicular to it. And that's what we're going to be calculating today. Where that line is, and then also how far that point is away from the point of intersection. So here we go with some examples. Please follow along and write this out. There is quite a bit of algebra. We're going to be calculating slope and distance and systems of equations. So if you do need to go back and review any of those, I'd be more than willing to help you, because we're just kind of assuming that you have those things under your belt. So I've included a graph for each of these. I think that will be very helpful to you. And I'm going to go ahead and get going. So it says that line L contains the points 1, 2, and 5, 4. So I'm going to put those points on the graph. I did this before too. I'm not quite sure why it does that sometimes. Okay, so if those are the points on the line, I'm going to go ahead and draw in that line. And I probably should be extending that line. So that you can see here where that's going. Then it says we want to construct a line perpendicular to L through point P, which is at 1, 7. So 1, 2, 3, 4, 5, 6, 7. 1, 7 is up here. So I want this line to be perpendicular, and it's not going to be okay to just kind of guess at what that is. We really need to make sure that we have it exact. So what I'm going to do first is I'm going to write the equation of line L. And this one here was line L. I'm going to find the slope of that line. So y2 minus y1 over x2 minus x1. So this is going to be 2 over 4, or the slope is 1/2. And then I'm going to pick either point. I'll just pick this first one and plug it in. Y minus the y value equals the slope times x minus the x value, and go ahead and solve that by distributing that half and then adding the 2 over. So y equals 1/2 x plus You could write it as 3/2 or 1.5 or 1.5, that doesn't really matter. And that looks like what this is. You know, this y-intercept's not right on one of those exact integers. This right here would be the equation of line L. So I'm just going to kind of sit on that for a little while. That will have to come into play later. The next step is we're going to find the equation of the line perpendicular to L, because I need to know how to draw this exactly. And again, we're not just kind of eyeballing it. We've really got to make sure that we have the exact equation. So for that, if you remember, perpendicular lines, their slopes are opposite reciprocals. So I'm looking at this and I'm seeing that, well, the slope of this line was 1/2. So the slope of the new line is going to be -2. And the point that it goes through is 1/7. So I'm going to do the same thing. I'm going to write the equation of the line. So y minus 7 equals the slope times x minus the x value. And go ahead and put that in slope-intercept form. So y equals -2x plus 9. I didn't need to necessarily write the equation for that to put it on the graph, but it will be really important for the next step. So I know that the slope is -2, and you may be able to tell where these lines intersect, and some of them will be a little easier like this. I'm still going to go through all of the steps, because some of the problems, the intersection won't be right on one of the coordinates for this next one. So the next thing we need to do is we need to figure out where this exact point is. So this exact point, I can tell is at 3, 3, again because it's right on one of those exact coordinates, but just to be sure, I'm going to set up a systems of equations, and you will have some that it looks like it's like part way, and there's no way to tell exactly without doing this. So I am solving the systems of equations to see where this line intersects that one. So I am going to write out these. So y equals 1/2 x plus 1.5, and y equals -2x plus 9. And we haven't done this since the Chapter 0 stuff, the algebra review. What I would do for this is, because they both equal y, I would just set this part equal to this part and use substitution for that. So -2x plus 9 equals 1/2 x plus 1.5. And I'm going to finish solving this. Oops. Subtracting 9. So this is going to be -2.5 x equals -7.5. And then when I divide them each by -2.5, I get x to equal 3. And then I have to plug that into either equation. I would plug it into this one here, because then I don't have to deal with the fractions. So -2 times 3 is -6, plus 9, y is also 3. Again, I knew that because it was the exact coordinate, but that won't always be the case, so I thought I'd show you what you could do. So now what I need to do is I need to find the distance between this point and the original starting point. I need to know how far that is, and that's where the distance formula takes place. So I'm finding the distance between 1, 7 and 3, 3. And the distance, I take the difference of the x values squared plus the difference of the y values squared. So I'm going to have 3 minus 7 and then 3 minus 1. This is going to be -4 squared plus 2 squared. So 16 plus 4. And you could leave it as the square root of 20. If you did want to write it out, you could also figure out whatever that is as a decimal. which is about 4.47 or 4.5, depending on how you're rounding. We also need to look at the distance between parallel lines. The distance between two parallel lines is the perpendicular distance. So I'll just kind of abbreviate so it fits in here. Between one of the lines and any point on the other line. So really we have a lot of different places that we could be measuring this. If I'm looking at a couple of lines, I could really pick any point and just come up with that perpendicular distance, or I could do it over here, or I could do it over there. All of those distances are going to be the same. Kind of looks like a ladder, you know, where you have all of those rungs are the same distance, or maybe like train tracks. All of those are going to be the same distance across. You could measure one and just know that it's like that for all of those when we have these lines that are parallel. I'll show you some places that it'll be easier to find that distance. So for this example, it says find the distance between parallel lines R and S whose equations are y equals negative 3x minus 5. So I'll go ahead and graph that. The y-intercept being at negative 5 and the slope being negative 3. I can't quite go down 3 and over 1 without just kind of going off the graph, but I could go up 3 into the left one. Up 3 into the left one, and I'm going to go ahead and just do this to kind of fill it up. And you'll see why in just a minute, why I want to make sure that it doesn't just stop kind of suddenly. And the next line, y equals negative 3x plus 6. Again, these have the same slope, so that's one way that I know that they're parallel. And I'm just going to extend this down. I don't know why this does this. Sometimes it just kind of jumps over when I'm graphing these points. Not quite sure why. And I'll do that line in red also. So what I need to do is I need to draw in a perpendicular. And again, this perpendicular can be any of these places. I have some foresight knowledge, and I know that I'm going to want this perpendicular to be easy to write the equation of. So if I start this perpendicular at either one of these y-intercepts, it'll be easier. So I'm going to say I'm going to start it here, and I want this line to be perpendicular to, both of them. So you can really choose either one, and it's going to have the opposite reciprocal slope. So what I'm going to do is I'm going to say let's pick this point here, and I want this line to have a slope of positive 1/3, because that's the opposite reciprocal of negative 3, and I want it to go through the point 0, negative 5, and I don't really have to do point slope form for this because I have the slope and I have the y-intercept. I would just write out like y equals mx plus b, so y equals 1/3 x minus 5, and that's my equation for one of the several lines that would be perpendicular to this. Next, what I'm going to do is I want to solve the systems of equations to see where that is going to intersect. It needs to intersect the red line because it already intersects the blue line there. So I want to know, where does this line, the line that's going to be perpendicular to both of them, intersect this line here. So I'm going to solve a systems of equations to find that. And again, I'm going to use substitution because both of these are equal to y, so I can set them equal to each other. And I'm going to add the 3x over and add 5. So this is going to be 3 1/3 x equals 11. This one doesn't work out quite as nicely when I'm doing this. So here x equals 3.3, and then I'm going to take that and I'm going to substitute it into either one of those equations. So if I have 1/3 times 3.3 and then minus 5, that's going to be negative 3.9. And I'm going to write that over here, negative 3.9. Again, this one doesn't work out quite as nice. And if I do the graph of this and I draw in this slope, I'm going up 1 and over 3 and up 1 and over 3. Again, you can tell here where that intersection is, and it's not on one of those exact coordinates. So this is kind of what I meant by sometimes you'll be able to tell exactly where it is and other times you won't. You can kind of eyeball this. This looks like it's about at 3.3 and then down 1, 2, 3, almost down there to 4. But without actually solving that system of equations, you're not going to know what that is. Now when I use the distance formula, I want to find the distance between this point that I chose. So that point being 0, negative 5, and that new point 3.3 and negative 3.9. And this will probably be a little harder to do. You won't be able to do it just in your head. You'll need to grab your calculator because we're going to be squaring some decimal numbers. So the distance formula, I'm going to be subtracting those x values and squaring it, subtracting the y values and squaring it, adding them together, and then taking the square root. So the x values being negative 3.9 minus negative 5, adding the opposite, and the y values being 3.3 minus 0. So just grab your calculator. I have my calculator here. Actually, I'll pull that up. Okay, so we have 3.9. This takes a little while to do. Negative 3.9 plus 5. I need to push equals in between. I'm going to square 1.1. So this is 1.21. And then I need to figure out what 3.3 squared is. And that is 10.89. So I'm going to write down that I have plus 10.89. When I add that together then, 1.21, and then now I'm going to have to take the square root of 12.1. This right here, ends up being approximately 3.47. Or if you wanted to, you could have just left that as the square root of 12.1. So again, this is one example of each one. I will include an extra example of each. So if you feel like you need maybe an extra example of this one or an extra example of the last one, you could watch those also while you're working on your work. I hope this helps, and we will spend a lot of time in class working on this and figuring it out.